Hello, pre-algebra students. Mr. Lawrence here with your flipped lesson for the weekend of January 11th. And I want to tell you we're going to learn some of those definitions that we didn't actually define, but we're going to learn them more in a visual way than actually writing out a written definition like you might in language arts class. Okay, we're going to be dealing with parallel lines that are cut by a transversal. For example, I have this line here. I'll call it line M. On this one, I'll call line N. And I'll call my transversal T because transversal begins with T. And what I will do is there are angles in here that are congruent, that have equal measure, and they have special names. And the first one are vertical angles. Whenever you're talking about vertical angles in a parallel set of parallel lines, you want to look for an X. And whenever you have an X, that means that the angles that are opposite each other are congruent. Those two angles are the same. Consequently, these two are also the same. And notice how I have two marks on the side angles and one mark on the top and bottom. It means the top and bottom angles are congruent and the left and right angles are congruent. Now this X can be oriented many different ways. It could be like a typical X. It could be even more like, I don't know, something like that, where it's kind of an X standing on one of the legs. It can be turned all different ways. If I take this X, see, ooh, I'm turning the wrong thing. I wanted to turn the X. But, oh, I guess I could group them together here. Control G, there we go. So the X can be oriented all different ways, and those angles stay congruent no matter what. Now on the X, it's, this looks like an X, that looks like an X. It's not such a big deal. But the other ones, some of the other ones have letters that will look actually different, but that's okay. So let's go up to these parallel lines and see if, look for my highlighters, see if we can find any X's. Well, I see an X right here. And that means that angles 1 and 4, let me get rid of these other X's here. Angles 1 and 4, angle 1 and angle 4 are vertical angles, and therefore they're also congruent. It also means that angles 2 and 3 are vertical. Angle 2 and angle 3. They're also vertical angles. Now I can move that X around. Those aren't the only vertical angles. I'm not going to list them all out. But if I look down here, I see another X, don't I? That would mean 5 and 8 are congruent, and 6 and 7. Okay. So that's the vertical angles, and they use an X. And let me get rid of those. And we're going to talk about corresponding angles. And when you see corresponding angles, I want you to think of the letter F. And when you have an F, these two angles right here are congruent to each other. See that? And just like the other one, the vertical angles, the F can be oriented lots of different ways. It could be laying on its back. It could be upside down and backwards. It could actually be flipped like that. Okay? So we're going to go up here and we're going to go look for some F's. And the obvious one, get my highlighters out. The obvious F is right here. And what that means is that angle 4 and angle 8 are congruent. Okay? Angle 4 and angle 8 are corresponding angles. But I see other F's. I do. I see other F's. I see a backwards F right here, making angles 3 and 7 congruent. I see an upside down F right here, telling me that angles 2 and 6 are congruent. The F can go any way you want it to go, as long as you don't change it. All right, so those are corresponding angles. Let me get a clean slate here to work with. All right, corresponding angles. Ooh, I lost the... Okay, that's all right. You can always rewind the video if you want to see that. Alternate interior angles. They have a letter, and their letter is the mark of Zorro, the Z. And in a Z, those are congruent. Now, again, just like the other ones, the Z can be oriented lots of different ways. It could look like an N. It could look like, hey, that looks like a Z. It could look like this. Boom, backwards Z, right? It could be backwards N. It doesn't matter as long as you have a Z. All right, so there we go. Let's go looking for Z's. I'm on a Z hunt right now. See any Z's? Z's. Oh, Z's. Where are you, Z's? Z's. Z's, 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 Z. Whoa. There we go. Kind of misdrew my Z there, but that's okay. Angles 3 and 6 are congruent. They are alternate interior angles. I can do a backward Z. I could go like this. Ba-doom. Angles 4 and 5 are congruent. Okay, that backward Z there. All right. Now, there's one more type. I guess I should list 3 and 6. So in this problem, angle 3 and angle 6 are alternate interior, and also 4 and 5. Angle 4 and angle 5 are alternate interior, and alternate interior angles are congruent. Just like vertical angles are congruent, corresponding angles are congruent. And there's one other type of congruent pair of angles, the alternate exterior. And I don't have a letter for those, but the alternate exterior are really easy to find because they have to be outside the parallel lines, okay? And then they have to be alternate sides of the transversal. So angle 1 is outside the parallel lines, right? And it's on the left-hand side of T, the line T. We'll come down here, jump over to the other side of T, and angle 8 must be congruent to it. Okay, so what that means is angle 1 is congruent to angle 8, and they're alternate exterior. To alternate can mean to go back and forth, and exterior means outside. So check this out. Angle 2 is outside the parallel lines, right? It's congruent. Go on down to outside the parallel lines. Switch sides of the transversal. It's congruent to angle 7. Okay. Well, this is pretty cool stuff because it allows us to do a more complex problem. Let's say I have lines M, N, and P, and they're all parallel to each other. If I know just a couple of angles, I can figure out every other angle. For example, let's pretend that angle A is 70 degrees and that angle T is 120 degrees. I should be able to figure out just about every other angle in here. Well, first of all, I'm going to go with angle D, and look at that, I have an X there. That means I have vertical angles. So angle D must equal 70 degrees. It must be the same as angle A because they're vertical angles. Now, I also have right here a Z. See my Z? Alternate interior angles. Well, if D is 70, I alternate, go to the other side of transversal, I'm down to angle E. That must also be 70 degrees. 70 degrees. See how simple this is? That forces H to be 70 degrees. Okay? Now, to get angle B, I'm going to remember that two adjacent angles that make a line are supplementary and therefore 180 degrees. So get angle B, I'm going to do 180 minus 70, and that's going to be 110 degrees. Now I can get angle F from this, and there's lots of different things you could do. You could go and do the vertical again, but I'm going to show you how to use angle F. Okay, or I'm sorry, yeah, angle F. Look at this. I've got an upside down F, and that means B and F are corresponding angles, which means they're congruent to each other. So that's 100 degrees. G is vertical with F, so that's 100 degrees. Okay, C is vertical with B, that's 100 degrees. Okay, it looks like I've got another F going on here. You can see my F. Let's see here, it's upside down and backwards. Looks like angles E and I are the same, so they are also congruent. Okay, now angle L is vertical with that one there, 70 degrees with angle I. Hey, look at this. B is 100, right? And it's outside the parallel lines. K is outside the parallel lines and on the other side of this diagonal, this transversal. They must be alternate exterior angles. Okay, I'm going to hold off on J and M for a minute, and I'm going to come up here and I'm going to fill in that U is 60 degrees. My reason? Supplementary angles. P is 120 degrees. My reason? Corresponding angles. That makes Q 60 degrees. Supplementary angles. And some of you are saying, well, isn't it corresponding with that? Or couldn't I use another? Absolutely, there's lots of different reasons. Q and N are vertical, 60. P and O are vertical, 120. Okay. R and U are vertical. S and T are vertical. 60 and N, or Q and M are corresponding. The only one I have left is J. And look at this right here. Let me get rid of these highlights, get them out of my way. What do I have here? I have a triangle. How many degrees are in a triangle? Well, 180. I have two angles of the triangle. I have a 70 degree, silly. I have a 70 degree angle and a 60 degree angle. I'm up to 130 degrees. All three of them must equal 180. So I'll do 180 minus 130 and I'll get 50 degrees. J must be 50 degrees. Now to check myself if I'm right, these three angles should make 180. 70, 60, 50. Well, 0, 13, and 5 is 18, and there you go. If I check this way, those three should make 180. Okay. These two here, this one, J and M, that big angle from there to there would be vertical with this angle, here to here. Okay. All right, that's your lesson for today. We'll be working with these on Monday. Mr. Lawrence signing off. Good night, everybody.